Simple interest pretty much. How to find your interest amount, how to find the future value, and how to find the present value. Compound interest is a little different. As you can see with simple interest, like I said before, if they charge you 5% interest, and we're going to switch gears a little bit. This is kind of looking at earning interest, like if you're investing money, like in an account. If our interest rate is 5% and we're earning 5% interest, we're only earning 5% interest on the initial value, right? That original principal amount we put in. So 5% of our $1,000 invested is $50. So every year we're going to get $50. That's simple interest. Compound interest is we're going to get 5% of our initial value the first year, and then the next year we're going to get 5% of the total from last year. So the original plus the extra interest we earned. Same thing with the third year. We're going to get 5% of our total from the second year. So our original plus all the interest we've earned up to that point. So as you see, we end up with a little bit more at the end. All right, so that's the difference between simple interest and compound interest. Okay, in both cases we invested $1,000. In both cases we had 5% interest rate and we waited 3 years, but this one we ended up with a little bit more because we're not adding on the same amount every time. We're adding on 5% of a new amount every single year when we're compounding annually. And that's the first situation we're going to look at, is if we compound annually, meaning we're going to gain interest every year. They're going to compound it at the end of the year. Okay. Excuse me. So if they say compound annually, right? So in the problem you want to make sure, does it say simple interest or does it say that that something is compounding? If it's compounding, you want this formula right here for compounding annually. And if it says compounding, always assume it's annually unless they say otherwise, and we'll see that in a little bit. All right, so you've got A, which is your compounded amount, right, or your future value, same thing, right? They're using a different phrase, but meaning the same thing as our other value A, right? Principal, interest rate, and N is the number of times, or the number of compounding periods, right? The total number of times they compounded our money, right? So if $7,000 is deposited in an account that pays 4% interest compounded annually, how much money is in the account after 9 years? So our principal, our interest rate, and if we're compounding annually, meaning once a year, and this is happening for 9 years, then the total number of times we've compounded is 9. So order of operations, add your 1 to your 0.04, take that amount, 1.04, raise it to the power of 9, then multiply by your 7,000. You should get 9,963.18. Right? If you want to be doing these in your calculator to make sure that you're matching me, just to make sure you're putting it in the calculator properly, really, because it's real easy to get that messed up also. All right. If you want to, I think if you want to pause, you should do it now. Yep, because there's the year turn. So hopefully your answers match mine. If not, you want to make sure that this is what you did. Make sure you added these together first. Make sure this was 11. You raised it to the power of 11 before you multiplied by 17,000. Okay? So now we're going to look at what if we don't compound annually. What if we compound more than that? Because you can. There's some common compounding periods are semi-annually, quarterly, monthly, daily. So if you compound your amount semi-annually, that means you're doing it 2 times a year, quarterly 4 times a year, so on and so forth. Okay, so what this does, it changes our formula a little bit, because now the I is being divided by M, or the number of compounding periods in a year. That's what M stands for. Okay, M is how many times you compound per year, and N is still the total number of compounding periods. So you want to be careful there, because before N was just however many years we had, because we were only compounding once a year. But now, let's say we compound semi-annually for 3 years. Well, if I compound semi-annually, that means M is 2, because I'm compounding twice a year. But I'm doing that 3 years in a row. So my N is 6, because I'm compounding 2 times a year for 3 years. Okay, so it's kind of like the N, you're doing the M value times how many years you're compounding. Okay, so keep that in mind, because those are real easy to get mixed up. And we're going to see kind of an example of that, example of the difference here. I've got one situation, right? We're starting with $10,000. We've got a 1.05% interest rate, and we're doing this for 3 years. So we're looking at 5 different situations here. If they say we're compounding annually, we know what to do. right? Same formula as a couple slides before, right? We got our interest rate. We're compounding annually, so once a year for 3 years, so our N is 3. But now, if we compound semi-annually, M is 2, because we're compounding twice a year, but that would mean that our N was 6, because we're compounding twice a year for 3 years. That must have been in my head before. Maybe that's why I used that as an example a minute ago. If I compound quarterly, right, that means I'm compounding 4 times a year, so I'm compounding a total of 12 times, 4 times a year for 3 years. Right? Same thing here. Same principle, same interest rate, but now my M, right, because I'm not compounding annually anymore, is 12 because I'm compounding monthly, so 12 times a year. 12 times a year for 3 years gives me a total of 36 compounding periods. And then finally daily, which would mean I was compounding 365 times a year for 3 years. So 1,095 compounding periods all together. And if you want to take a moment and try to put some of these in your calculator, make sure your answers match mine, just to make sure you're putting it in the calculator properly, because it's real easy to get that messed up. All right, make sure you do your division first, add, raise that to the exponent, and then multiply by 10,000. Trying to round the fewest amount of times as possible so that it gets the most accurate answer. Notice how the more we compound, the more money we end up with. It's not a big change, but it's a little bit. It'll make a difference eventually. Okay, if you're going to pause, there's one for you to try underneath, so pause now. And hopefully that's what you got, right? Compounded semi-annually, so that means twice a year. For 5 years would give us 10 compounding periods. Same thing here. Monthly, that means 12 times a year. For 2 years, that's 24 times total. Division, addition, raise to your exponent, then finally multiply. All right, take care of that parentheses first, then the exponent, then multiplication. The only other time of compounding you can do is continuous compounding, right? They figured out, well, the more we compound, the more money we get, so let's see if we can compound continuously. All right, and you want to look for that key word, continuously. So if you're compounding continuously, then it's this formula right here. Remember that E from last week. That E is an actual number. It's not a variable that represents anything. It's an actual number. Like they came up with the pi symbol to represent 3.14, blah, 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 blah. E represents this 2.718, blah, blah, blah number that we looked at last week. Okay, so you're going to do the principal times whatever you get when you do E raised to the power of RT, R being your interest rate, T being your number of years, right? So suppose we invest $5,000 at an interest rate of 3.1% for 4 years, all right? Find the compounded amount, and it says compounded continuously, okay? So that's a key to us that we're using that formula. So we plug in everything, our rate, our time, our principal, right? Our exponent ends up being 0.124. You want to raise E to that 0.124. If you have an E button on your calculator, great. If you don't, use 2.718. Raise it to that exponent. Once you have that, then multiply by the 5,000. That should be the last step that you do when you're simplifying these. Okay? I believe I'm going to have an example, so pause now if you want to try the next one on your own. And there it is. So hopefully we match. If you got it wrong, you might want to check and make sure that you converted your percent properly, right? Make sure you did E to that exponent before you multiplied by 7,500. All very common mistakes, all right? And here on this last slide, just so you're aware, I've kind of summarized everything and put it all in one place for you. You are welcome, all right? It tells you what all of the variables represent, right? So if they're asking for, you know, compounded amount, and you're like, well, which one's that? What does that mean? They're looking for the capital A. Okay, compounded amount, maturity value, future value, all means the same thing. Okay, except they'll usually refer to future and maturity value if it's a simple interest problem, compounded amount if it's a compounding problem. And then here's all your formulas for simple interest, compound interest, and continuous compounding, depending on what they're looking for. So a good strategy would be to figure out which one of these categories you're in. Does it say in the problem, does it say simple interest? Does it say compound interest? Or does it say continuous compounding, right? That will place you in one of these categories. From there, you just look at what they're asking for. If it's a simple interest problem and they want to know the future value, you know you're using this one, okay? For example, If they're saying compounded anything other than annually, remember you're going to use this. Compounded monthly, you're going to use this guy, right? And then M and N are there. All your variables are there telling you what they mean, just in case you forget, right? If it says continuously, compounding continuously, that's this guy, right? Here, if they're looking for the compounded amount, here, if they're looking for the present value. Okay, so that's there for you.